reduce our dimensions as much as we can. So we would only select the relevant features or attributes to our study. So we have 200 of them. Do all of these really apply to our goal that we're trying to achieve? Are all of them useful in my analysis? If not, remove them. We will only keep the most important ones. So that's one way to reduce our data. Another way to reduce the data is sampling. We're not going to do the analysis on the entire data. We will take a part of it and do analysis on that part. So we only take a sample of the data which we believe that our sample is representative enough of the entire population to where we can achieve our goal by analyzing the sample only. Or we can divide the data into subsets and do our analysis on one of the subsets only. Or on each subset separately, and then combine the results. So I mentioned feature selection, which is select the most relevant features only, and we have methods of how to do that, but really the best idea to do that is to speak to an expert in that domain. So let's say these objects here are patients that have some disease. Let's say they have heart disease. And this is values of the medical exams that was performed on them. So we want to know if this patient has a heart disease or not, based on the data. Which of the attributes are we going to remove? We don't know. We're not medical doctors. We are computer programmers. We're doing data mining. So we're going to ask the doctors, which of these makes sense to you? Which of these values would you use when you're placing diagnosis of this patient? Which exams would you use to determine if he has heart disease or not? And if the rest of the data, remove it. So we can talk to the expert in a specific domain, because this could be financial data. This could be try to determine if this stock will make profits or it will lose its value. So then we have to talk to the financial guys that gave us this data. Yes.
Is it possible that we can identify information from the features that the doctors would not know to eliminate from the IT side, to identify, for example, if two different features are have a high correlation coefficient between the two. So one is pretty much very similar to the other, so one can be eliminated.
Okay, yes, that's definitely possible. We can calculate, we have a way to determine correlations between attributes. But what we're doing right now is, before we do our analysis, we are cleaning up our data and preparing it for mining. So we are removing some of the attributes because we don't want to have curse of dimensionality, and we want our algorithm to run faster and produce better results. we need to remove some of the attributes if we have too many of them, compared to the number of objects that we have in the data. So we're trying to select the best features or descriptions that are relevant to our study. They could be data there that's important for some other reason, but what is our goal? What are we trying to accomplish? And leave only the relevant features in there. After we do the processing, we gotta find all kinds of correlations and trends in the data that we can present to the medical doctors. And that's why they give us the data, right? To provide them with something that they did not know before and discover some patterns and trends that can help them to accomplish their goals. But before we can do that, we have to clean up the data. And one of the things they're doing is to remove some of the features and only select the most relevant features. So, when we plotted this object in the space, we can determine that some of them are similar to each other because they're close to each other. If they're close to each other, let's say x1 and x2 is close to each other, this means that their values of the attributes are similar, which means these objects have similar properties. So they must be similar objects, right? x1 value for b is exactly the same. For x1 and x2, value for b is b1 for both of them. For a, one has 0, the other one has 1. 0 is much closer to 1 than it is to 6, right? So x1 is a lot more similar to x2 than it is to x4. And if you look on the picture, x4 is way over here. It's far from x1. So we have a way to determine how similar objects are to each other based on their values, but based on where they are when we plot them. What is their distance from the rest of the objects? So we have some formulas that we can use to calculate the distance. One of them I already mentioned earlier. Was the distance between x2 and x5 by subtracting the values for one attribute from for the first object from the value for the same attribute for the second object, and then for the second attribute. So that was the Euclidean distance. That's one type of distance that we can measure. Distance between objects can be used to calculate similarity or dissimilarity between the object. Similarity is numerical measure of how alike the two objects are. The higher the similarity, the objects are more alike. Usually these values are between 0 and 1. If the similarity is 0, this means these objects have nothing to do with each other. If the similarity is 1, this means the object is exactly the same as the other object. For example, what is the similarity between x1 and x1? 1, because it's the same object. So the similarity of the object to itself is 1. This similarity will be exactly the opposite thing. the Euclidean distance, that's the one I mentioned earlier. So if we take a ruler and just measure the distance here on the board from x2 to x5, that will be the Euclidean distance. This is the distance that we're used to in our everyday life. That's the distance we measure in centimeters or in feet or in inches or in miles. So, Euclidean distance, the formula for that is square roots of the difference between the values for the two objects for the same attribute. Starting with the first attribute. So in this case it's k. And we take the sum of all of them, attributes. So k will be from 1 to n. And this is squared because to avoid negative values. So if we have two attributes, so one of them was A, the other one was B, then we will take the distance, then our distance will look like this. For the first object, x, 1 will be for the first attribute difference between values for A, one is has a 0, the other one has a 1. Difference between values for B, both of them have B1. This will be the Euclidean distance between object x1 and x2. So, how much is that? 1 minus 0 minus 1 is 1, squared is 1. B1 minus B1 is 0. So it's equal to 1. The distance between x1 and x2 is equal to 1. Now, if we calculate the distance between x1 and x4, it will be a much bigger number. You see, whereas x4 is pretty far away.